All right, guys. Now remember, back in chapter 10, section 1, we focused on the sample space for a single six-sided die. Well, in chapter 10, section 4, we're going to be analyzing the sample space for two six-sided dies rolled at once or rolling one six-sided die twice. Now, when you roll two six-sided dice, that is a pair of dice. Or if you roll one die twice, that gives us the same type of sample space, which is the sample space for a die with two outcomes, one after another. So, there are 36 different outcomes when you roll either a single fair die twice or two dice. So the total of my sample space is 36. It is very important that you analyze and you memorize and you learn the sample space for rolling two dice or a single fair die twice. The colors that's highlighted in red is the first roll. The one highlighted in blue is the second roll. I don't know what's going on down here with that color. So let's say I roll a die twice. An option is the first roll landing on the 2, the second roll landing on the 5. That's going to be the pair of 2 and 5. The first roll can be a 5. The second roll can be the number 3. That is the pair of 5 and 3. Let's take 2, 5, and 5 and 3, for example. And it says here, or the question says, hey, find the sum of the pairs. To find the sum of the pairs, you're going to add the first roll value and the second roll value together. 2 plus 5 is 7. And if you look here, oops, I should have turned off my highlighter. If you look here, in the same exact position in the table to the right, has a number 7. This table right here represents the sums. The sums of when you roll and get the two numbers and then add it together. If I say find the sum of 5 and 3, we know 5 plus 3 is 8. And if you look here, it corresponds in the same location because 5 plus 3 gives us 8. So in the next question, number 4, we're going to answer 4 parts, and we're going to use this table and analyze it to find the answers to the following questions. Let's reset. And this is when you're rolling a single fair die twice, which is a six-sided die, or you're rolling 2 of these dice, what makes a pair of dice. Now, it says an ordinary fair die is a cube with numbers 1 through 6 represented by painted spots. Imagine that such a die is rolled twice in succession and the face values of the two rolls are added together. This sum is recorded as an outcome of a single trial in the probability experiment, of a random experiment, Compute the probability of each of the following events. Round your answer to 2 decimal places. And if the fraction needs to be reduced first, I'm going to reduce the fraction first before I divide. Now, it says event A, the sum is greater than 6. So the probability of A. And once again, A has been defined as the sum greater than 6, which means when I add the two pairs together, it gives me a sum that is greater than 6. I'm going to use the table to the left first, and then I'm going to show it on the right. Pairs that add up to a number greater than 6. That's going to be 6 and 1, because 6 plus 1 is 7, and that sum is greater than 6. 5 and 2, 6 and 2. Add them together. 5 and 2 gives us a sum of 7. 6 and 2 gives us the sum of 8. 4, 3. 5, 3, and 6, 3. 7, 8, and 9. 3, 4, 4, 4, 5, 4, 6, 4. 7, 8, 9, 10. 2, 5, 3, 5, 4, 5, 5, 5, and 6, 5. 7, 8, 9, 10, 11, 12. And when I say that, I'm counting the sums, what they add up to. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and 6, 6. All of these pairs that I circled gives me the sum that is greater than 6. You do not include 5 and 1 because 5 plus 1 is 6, and the sum of 6 cannot be greater than the sum of 6. You're not going to use 4 and 1 because that gives us the sum of 5. The sum of 5 is less than the sum of 6, not greater than 6. So if I count how many pairs that I have, that'll be 21 out of a total of 36 outcomes. So the probability of having a sum greater than 6 when I roll a single fair die twice in succession is going to be 21 over 36. Both 21 and 36 are divisible by 3. So divide 3 from the numerator and 3 from my denominator. 21 divided by 3 is 7. 36 divided by 3 is 12. So 7 twelfths. And as a decimal, we're going to divide and round the two numbers after the decimal as approximately 0.58. Let's clear that. Now, I'm going to attempt it using the second table. And then after that, I'm going to stick to using the second table for the rest of the videos. Or I should say for the rest of this video. Now, the sum is greater than 6, right? So that means all numbers here that is greater than 6 is going to be highlighted. So 7, 8, 9, 10, 11, 12. Highlight all those values that are greater than 6. And when we count them, it gives us also 21. Once again, the sum is greater than 6. So all these values here that are less than 6 is ignored. All right, guys. Hope that makes sense. Let's move on. Now, it says B, event B, the sum of the numbers is an odd. The sum is an odd number. Excuse me. So when we add up the two pairs, we add up the two rows, it has to be an odd sum. So I'm going to clear this. So an odd sum, 3, 5, and 7. Highlight all the odd numbers, 3, 5, and 7. 5, 7, and 9. 5, 7, and 9. 7, 9, and 11. 7, 9, and 11. If you was to use the first table, you must look at which ones add up to an odd number. 1 plus 1 is 2. 2 is not an odd number. We do not use that. But it'll be 2 and 1, 4 and 1, 6 and 1. They all add to odd numbers. And then you continue the same process. 1 plus 2, 3 plus 2, and 5 plus 2 all give us odd sums. When you continue the process, you're going to be circling 18 different options. So the probability of having an odd sum is going to be 18 out of 36. 18 odd sums out of 36 total options. And when I reduce that, I can divide the numerator and denominator by 18 because 18 and 36 are both divisible by 18. That's going to be 1/2, which equals to 0.50. So I hope you understand that. In this case, we're looking for which pairs, when we add them, gives us an odd output, an odd number. Now, event C and event D gets more complicated. Event C wants us to find the sum is a multiple of 4 and 6. So the probability of C is a multiple of 4 and 6. Let's list out the multiples of 4 and 6. Now remember, the highest sum when we roll 2 fair die or 1 fair die twice is going to be 12. So our sum cannot exceed 12. So the multiples of 4 is 4, 8, and 12. The multiple of 6 is 6 and 12. In this case, we want to find all the outcomes that adds to 4, 8, 6, and 12. The word or represents union, represents addition. Put them together as one. So go into the table onto the right and identify all the pairs that has the sum of 4, 6, 8, and 12. And then we're going to count them. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 pairs out of 36 total has a sum that is a multiple of 4 or a multiple of 6. So 14 out of 36, and we're going to write multiples. We can divide the top and bottom by 2, excuse me. When we do that, we get 7 over 18. And as a decimal, let's divide that. 7 divided by 18. That's going to equal to 0.39 when I round the two numbers after the decimal. That 8 will make the other 8 round up to a 9. All right. And now the last event, event D. It says the sum is not a multiple of 4 nor 5. So the probability of D. The kids outside of my window is wilding out. Now, what are the multiples of 4? We already did that. That is 4, 8, and 12. For the multiples of 5, numbers using 5 when you multiply, 5 and 10. If the sum is not a multiple of 4 nor 5, we're disregarding the sums that adds up to 4, 8, and 12, and disregarding the sums that add up to 5 and 10, and taking everything else. Those sums are disregarded. So going back to this table of sums, the ones that are says 4, 5, 8, 10, and 12 are disregarded, which leaves us with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 pairs have a sum that is not a multiple of 4 nor 5. Let's double check that. Yep, that's correct. So the probability of having a sum that is neither a multiple of 4 nor 5 is 20 over 36. Divide the numerator and denominator by 4, since that is a greatest common factor between the two. That is going to be 5 over 9. And when we divide that in the calculator, we get approximately 0.56. And that is it to this video, guys. Hope you enjoyed it. Run a little bit more than 15 minutes. Hope you understand it. If you want more practice for rolling 2 dice or having 1 die rolled twice, you can look at the exam 2 review and watch the solution videos to that. I'll see you soon. Take care.